Hey everyone, welcome to the Open Protocol meeting. Sorry for the slightly late start, just a quick technical glitch as per usual. So the Stellar Protocol meeting, in these meetings we discuss and plan for upcoming changes to the Stellar Protocol. And today we're going to talk about something very exciting, Project Jump Cannon, which is going to bring smart contracts to Stellar. So just quick intro, as most of you know, Stellar was launched in 2014. At the time, there was a very deliberate design decision to keep things simple, right? So only support a fixed repertoire of transactions. But at this point, after a ton of feedback from the ecosystem, it's clear there's a need for more flexibility. So developers, they're interested in building applications that rely on submitting custom Turing-complete contract code, right, to run in the transaction execution phase of the network. So essentially, people want smart contracts. So in March, we officially kicked off Project Jump Cannon, and there's a link to the announcement in the meeting description. And after a very thorough examination of the existing smart contract landscape, we made a decision to build it on a WebAssembly runtime, WASM for short. So if you want to know more about the selection process, there's also a link to a blog called Project Jump Cannon, Choosing WASM. And that will sort of help walk through that decision, the evaluation that led us to where we are today. But today, we're actually going to start to get into the protocol changes necessary to accommodate that decision. So we're going to start by talking about a core advancement proposal, CAP 46, WebAssembly Smart Contract Runtime Environment, which, as you can probably guess by the title, specifies the lowest level code execution and data model components of a WASM-based smart contract system for the Stellar network. Once we talk about CAP 46, we'll also start to ask some general questions about how smart contracts should interoperate with the network. This is, as per usual, a technical discussion, so if you want to keep up, I suggest taking a look at the CAP as well as the discussion thread about it. Those are both linked to in the meeting description. And then if you're interested, you can also join the conversation about smart contracts. You can do that by participating in that thread that's linked to here, or by joining the Stellar Developer Discord, which is where we're having all the Jump Cannon discussions so that the work is open, participatory, we're doing, and really follow along on the Stellar Developer Discord. Okay, CAP 46. So CAP 46 came out on Friday. I think there's been a lot of back and forth on the mailing list, though, over the past few days. A lot of questions asked, but I'm going to pass it to Graydon. Graydon, I guess to start off with, is there anything that you want to tell us about CAP 46 and or about any issues that you have that you'd like to discuss about it today?
Thanks. Yeah, there's lots to discuss here. I want to give a little bit of background because this is in some ways an unusual CAP. Oftentimes when we write CAPs, they're directly changing the protocol, or they're proposing to directly change the protocol that people are using. And CAP 46 is a little bit weird in that it contains protocol contents. There are new XDR definitions like there would be in most CAPs, but none of them can actually be used. This is a building block for other CAPs. And so if this CAP, for example, were accepted as is tomorrow, there would be no new messages that you could send on the network yet. So this is just a building block CAP. It's a piece of vocabulary that we want to talk through the potential uses for in the future, but without actually committing to a specific transaction format, specific ledger entries, anything like that. This is vocabulary in particular for interoperation between two environments. So the way to think about this CAP is that it's describing two different places inside of Stellar Core where code can run, the guest and the host. And so that division between guest and host is a key concept that's being introduced here. And most of the CAP is a discussion of how the guest and the host are going to relate to each other, both their calling relationship, what values can be passed back and forth between them, and then the types of data that will be stored in this particular proposal. The way we're discussing data storage actually involves a split, and it's a split that's brought about by idiosyncrasies of the WASM runtime interface, which is that you can't really pass complicated data types back and forth. And there's a few other reasons for this. It's actually there's a very large rationale section of the CAP that tries to lay out our thinking as we explore different options here. There's an efficiency argument, code size, there's a compatibility, the ability for third parties to browse and interoperate, for contracts to interoperate with one another. There's a whole host of different reasons for splitting data the way we are. But really, the way to think about this cap is, and I've had this conversation with a few people so far, to picture in your mind a sort of a 4-quadrant diagram. Upper left, upper right, lower left, and lower right. And in the upper level, you've got the host and guest environments on the left and right. Okay, so those are at runtime while code is executing. There's these two environments that are communicating with each other and sharing access to a data model where much of the data is stored on the host side, but the guest has these little handles that reference into it. And then in the lower 2 quadrants, you have corresponding to each of those types of data, what we would call the values, which can be handles, and the objects. There's an XDR layer. So in the upper 2 quadrants of this diagram, you've got the host and guest at runtime, where values are in memory and the contract is executing. And in the lower 2 quadrants, you've got the XDR representation, which is sort of data at rest. And in fact, quadrants are quite the right description, because the entire lower layer of this diagram is essentially all XDR. But there's a correspondence between values that are accessible in the guest side and the SC val XDR type that's presented in the cap. So the cap introduces these value and object types, and it introduces the split between the host and the guest environment. And that vocabulary is a sort of background of what we're trying to get laid out here. Now we have a prototype implementation of this. We actually, at this point, have 2 prototype implementations, because we've done a version of this in C++ and a version of it in Rust. We're fairly confident that this is a structure that works well, and that it allows very small and highly interoperable guest code to run in a WASM runtime that is connected to a host that has these host objects. And so most of the discussion around this cap so far has actually been like which host objects to start with, because there's a potential repertoire of multiple types of host objects, and a little bit around the value representation and bit packing and stuff like that. But there's not a lot of in many caps, there's semantic rules to talk through in terms of a sequence of events that occur in response to a transaction or an algorithm that's implied or something like that. There's not a lot of verbs in this. This is really more of a nouns cap, right? It's laying out a vocabulary of things that will exist in memory and or on stable storage in XDR or being sent over the wire. And so you can imagine all sorts of operations happening. All the actual operations that will occur on this data model are essentially left to later caps. There are things that still have to be worked out. We're still sort of experimenting with that. But because smart contracts are such a big project and there's so many different parts to smart contracts, we wanted to try and split out meaningfully digestible pieces of the problem and review them, talking through, have community input on them, and ultimately as software engineers, implement and merge them piece by piece. And this is the first piece. So that sort of gives a little bit of background on it. There was one other thing I wanted to mention.
Graydon, I actually do have one high-level question for you. I know you go into this in detail in the cap, but can you just give a brief overview on the specifics of the value object split? Because that's something that is very unique in the world of blockchains. I think that Elrond is the only other blockchain that we saw that does something similar.
Yeah, for sure.
So what is the alternative and why is this better?
Totally. So an analogy that a lot of people have, this was actually the thing I wanted to talk about. I just remembered, so I'm glad you brought it up. There's this analogy that a lot of people have been using when we're talking about this that I thought it would be good to bring up here, which is that if you've used a web browser, you can really think about this in terms that are going to be very familiar. So in a web browser, you program your web pages in JavaScript. but the web browser itself is a very large piece of code that is not written in JavaScript, right? So like some of the front end is written in JavaScript, but a lot of the web browser is written in C++ or Rust or C or some other low-level systems language, and it's compiled ahead of time, and it's essentially a platform for the applications to run on. And the JavaScript applications, if you've written JavaScript, you'll know that you often have object references that aren't references to JavaScript objects. Right, you can have a reference to a DOM node or a window or a media container or an XML HTTP request or something like that. And these objects, they're not like the other objects, right? They're not like the JavaScript code that you have. You can't inspect them. You can't find the source code to them. They're just sort of out there somewhere. Where they are is they're in the host environment. They're supplied by the C++ platform that you're running on. They're much more efficient. They can do things that the JavaScript code isn't capable of doing. They're often much larger pieces of code, and so if you had to ship them over and over again with every application, your application would be gigantic. And so there's a sort of by being part of the platform and the environment in which your JavaScript is running, they are almost like a library that you can call of very fast, very reliable, very common features, but that you operate at some distance from, right? If a function call goes into them, you don't get to break on your JavaScript debugger in the middle of that function call, right? It comes back to you. And then you get control back in your guest code when it returns. So we're approaching this this model, and as you said, it's the same model that I think the LRON network uses in a similar fashion, where we're coming up with a set of objects that the platform will provide that are implemented in C++ or Rust, and they're kind of baked into the platform. They're things that all or quite a lot of smart contracts are likely to want. And so ahead of time, the Stellar Core developers, ourselves and anyone else who wants to contribute to it, would have created this repertoire of extra objects. And those objects are, again, fast. So they're gonna, they're not gonna be written in WASM. They're not running on the virtual machine. They're written in native code. They're much larger. Typically, there's a large code footprint that supports them that will not be included in your smart contract. You don't have to include code in your smart contract. Your smart contract just calls them, and so your contract code is much smaller, but you operate them at a distance. So you have this reference to a host object when you're working on it, rather than running in the memory of your smart contract. So your smart contract has a little linear memory. It has the WASM virtual machine has its own memory, and so you can write code in whatever language you're writing in. I think most of our smart contract source languages are going to be. We're looking at actually at mostly Rust there as well. Interestingly enough, and so you could write a data structure in Rust and have it running in the WASM virtual machine. Just like you would have a JavaScript array or something running inside your JavaScript program, but we're also going to try and provide almost every object that you want as a host object, so that you don't actually have to compile anything into your contract except for a handle. And so this handle, which is essentially a pointer or a sort of quasi pointer, it's not actually a memory address. It's just an integer number that starts from 0, counts up as we allocate host objects. But these typed handles that you'll be operating on and passing to host functions refer to host objects, but they don't actually hold the host object in the guest's memory. And so again, there's a variety of benefits. One of the benefits I haven't mentioned yet so much, but it's in the rationale section, and we've talked about it a bunch while we were working on this, is that objects in this model have a corresponding XDR form. And when we've looked at a lot of smart contracts, most smart contracts spend most of their time, from what we can tell, if they're not doing cryptography. Obviously, there's the special case of doing cryptographic operations, which we'll also get to. But a lot of them spend a lot of their time serializing and deserializing their data store. So the smart contract is invoked and it's given a byte buffer, and then it spends all of this time in its virtual machine running virtual machine instructions, but those virtual machine instructions are just like inspecting a byte buffer and copying values out of it into a data structure in memory, then operating on the data structure in memory, and then reserializing it back to a byte buffer. And that's a little bit weird for a few reasons. It's not a good efficient use of computational resources, because that's like compute expensive work, and you're doing it on the virtual machine instead of the host where it would be in native code. And it's very likely to be shared or shareable, right? If you were using a data structure that is similar to other data structures that other people are using, the idea that you would need to do custom serialization and deserialization as opposed to just reusing a library that does it is a little funny. It's sort of it's making every smart contract ship redundant duplicate contract code that does the same thing as someone else could do. And on that note, with respect to commonality, the more the data types are common between smart contracts, the more you can interoperate between smart contracts. So if smart contract A wants to call smart contract B, it's going to want to pass data. It's going to want to pass arguments, right? Accounts and amounts and maybe vectors containing things, maybe large numbers or cryptographic data types or whatever. And in order to pass data from one contract to another, I mean, a contract is just a program. And for two programs to interoperate, they have to have a common data language. And so if you assume that you're going to have this interoperability requirement between contracts where they share some kind of data vocabulary, then necessarily the serialization and deserialization code has to be shared. And so factoring that serialization, deserialization code out and having it be part of the platform and having the user not actually have to ship serialized, deserialized code, but having the XDR pulled out of a ledger entry and turned into host objects, and then just handing handles to those host objects to a contract, saves the contract from shipping any of that serialized, deserialized code. It saves the contract from having to deal with compatibility issues because everyone's using the same data model. It just seems like a win all around. You know, every time we sort of thought about this problem from another angle, we found another way in which it seems advantageous. Third-party browsers, for example, would be able to browse the stable data format, as opposed to many smart contract systems. Every data value that the smart contract saves into the blockchain is just an opaque byte blob that no one can inspect. If we have a common data type, such as the one that's presented here, all of the ledger entries will be at least structured so you could browse them. Now, you might not be able to make total sense of the contents of it, but it would at least have some structure that you'd be able to browse, which would make diagnostics easier. It would make writing third-party adapters to consuming events coming out of the system easier. It would make testing easier, creating mock data, attaching fuzzers to it. There's all sorts of advantages to using a common data format. So I try to lay some of them out in the rationale section here, but it really does seem like this is a huge key to a better design for smart contracts than what we've seen in a lot of other platforms. And so again, that's sort of why this made up the first building block cap, is because if we do adopt this approach, we'll be deeply structured by this decision. And obviously, if we don't adopt it, if there's really strong community feedback, this is a terrible idea, nobody likes it, if all the technical review says this is impossible, we won't be able to make it work, or it's there's no way you can ever come up with common data types that everyone would find agreeable, that's really important information to know, because it does seem very, very appealing. But if it's not going to work, that will also change our strategy very dramatically. So I've talked a lot right now. I don't know if you have any other questions or other things that you wanted to discuss about it. There's some detail in the cap. Most of the conversation we've been having so far is just like around missing detail in the cap, or debating the set of objects. That's one of the big questions. Is like, which objects do you include as your sort of MVP first pass? What host objects do you include as your baseline?
So I actually have one follow-up question before we go deep into the details, which is, how do we encourage people to use these managed objects rather than to do something, very offensive on the like the source language side, just because they can?
Yeah, so this does not, this of course this does not preclude, you know, shipping your own encoder and decoder and just storing. There's a data type in this cap called a binary, which is just a raw byte array. And so if you want to store a raw byte array and you want to ship the serialized deserialized code yourself, we're not going to be able to stop you. I mean, it's a Turing complete environment, right? So that's like trying to prevent someone from computing a particular function. It's just not. It's against the whole point of the platform to try to prevent that. But I think you'll have a fairly strong disincentive just from the fee model. If there's any type of pricing of resources here, which, you know, there has to be in order to make to arbitrate access to CPU and disk resources on the validators, it will be a lot more expensive to do it that way. And so I think you'll just, my hope anyway is, obviously this won't work very well if the fees turn out the other way, but my hope and my assumption is that you'll be saving a ton of you know, whatever gas metering fees the system is charging users by using host objects, because they're so much faster and efficient.
I mean, is it time to start digging into some of these details, or does anyone, I guess the first question is, in general, do people feel pretty good about this model?
I mean, so I have kind of a meta comment, which is that it seems to me, you know, having, you know, been involved in like a few standardization efforts, it seems a little weird to be contemplating a change of this scope without like a requirements document first to reference. So like I have a bunch of nits, but to some extent it's going to be like, who knows, because like we don't know what the requirements are and aren't, right? So so I have huge concerns about the use of floating point values, for example. It just seems like I can think of like a million bugs that like really catastrophic bugs that are that could happen, right? Like certainly in my lifetime, like literally hardware has implemented IEEE floating point incorrectly, right? On top of that, there's like from one release to the next of like the compiler runtime, there might be small changes, like they might use like a different not a number representation, because there's like tons of ways of representing not a number, things like that, you know, positive, negative, zero. So, but, you know, maybe we need it, maybe we don't, but like, this is just, without a requirements document to go back to, like, how do we know whether some of these things are good ideas or not, or whether they're going to serve our purposes?
So David, we've been, you know, we've been like, the one thing that we have going for us right now is that there's a lot of prior art in the world of smart contracts. And we have made a list of like sample smart contracts that we are interested in. Seeing like,
so that should be like a SEP or something, or there should be like, this should reference like a document saying like, you know, these are the requirements for like smart contracts on Stellar, right?
Okay. That makes sense. I can work on that. Maybe in the meantime, if you have specific concerns, like the floating point thing sounds like something we might want to discuss.
I could speak to that a little bit. I mean, just very briefly. WASM as a spec does include instructions for floating point. This cap doesn't specifically preclude them. We've talked so far somewhat seriously about the possibility of actually filtering them out, and of saying that all the floating point instructions equal invalid contract. Just again to sort of to allay fears, because you're not the first person who's expressed fears around floating point. Now, personally, myself, I'm a little bit more of a floating point believer, so I'm not as concerned about that. There are two sources of what we might consider non-determinism or wiggle room in floating point behavior that are left open in the WASM spec. In all other respects, WASM just delegates directly to IEEE 754, and if you do not implement 754 correctly, you're in error. That's that. And 754 has not actually changed in 40 years. So I mean, I think that's actually a fairly stable thing to point to.
Yeah, but it's not the standard so much as like implementations of it, which have been buggy, or
And there have been
think
like 2 CPUs shipped in my lifetime that had bugs, and they were like very high priority fixes. So I think saying like that we
just
can't
saying like okay, like but these are like exactly the CPUs that would be like running Stellar Core, right? So this would be like catastrophic for Stellar Core. So again, if we have a requirements document and say here's like 10 contracts you want and like 6 of them need floating point, then we need floating point. If 0 of them need floating point, then it seems crazy.
No, I agree that we can decide whether or not to have floating point. I think referring to the fdiv bug as a reason that floating point is not a reliable piece of software is hyperbolic. I don't think that's a fair objection. Floating point is very well defined at this point.
What about compilers that like, you know, use 80-bit when it's in a register and 64-bit when it's been spilled to memory, right? Like things like that.
So 80-bit floating point is not an accessible format in WASM. You only have access to the 64. All the operations.
No, but I
are
mean, like I would consider it's like a bug in the runtime that it would like accidentally use 80-bit. But you're saying like
it's not available. It's literally not available on the target. The WASM target does not have extended floating point. There is.
At the same time, I feel like the suggestion to like figure out if there's a requirement for floating points before getting too deep into what might go wrong. I think it's the right one.
Okay.
So Tomer, you're going to make that awesome set.
Yep.
Okay. Are there other, so floating points is we're putting a bracket on it. It may come up and it may not, and we can have that discussion. Are there other like concerns like that we should get into now?
Well, I think like the big one is concurrency, right? Like, do we require, like if the requirements include sort of performance, then we need to be able to run smart contracts in multiple cores in parallel, which entails one set of requirements, like making sure that we don't run conflicting smart contracts in parallel. If we don't need performance, then we don't need that. But it seems like that again is something that we need to decide pretty early, and it needs to be driven by requirements.
Yeah, I can speak to that a little bit. That is definitely something that we have been extensively considering and have in fact a prototype plan for. As with everything sort of above the single contract, single VM interface, it's not specified in this cap. So this cap doesn't, for example, talk about ledger entries at all. And so any concurrency issues relate to access to the ledger. There is essentially no, there are no concurrent host objects in this model, and I'm happy to spell that fact out. That these host objects are isolated to a single VM. The single VM is single threaded, or sorry, to a single host context, which may have multiple VMs, but they are executed on a single thread in serial. So there's no concurrent access to host objects whatsoever in this cap.
Right. So this seems potentially not workable depending on our requirements.
Let me finish. Concurrent access to ledger entries is planned. So the ledger would be the shared concurrent data structure, the thing that it's meaningful to talk about concurrency with respect to. And that's something that we will be discussing in a later cap, because the transaction format for invoking transactions that we have planned includes sort of a trick or a standard pattern from the deterministic database literature, where transactions carry static read-write sets sort of stapled to the transaction. So the semantics are strict serializability, with the caveat that it's implemented by deterministically partitioned read-write sets, such that there's no actual contention. There's no requirement for concurrency control, because the concurrent executions are all on disjoint data.
I see. So an account ID, for example, it's a type, but that doesn't
exactly
correspond to an actual account. It's just it's just the public key or whatever.
And the contract literally can't see any data that it hasn't pre-declared as part of its read-write sets. So there's essentially a static data structure on a static schedule for each transaction set that partitions it into non-overlapping partitions, and then they can run concurrently. So I agree. It's a concern. It's something that we have been thinking quite a lot about. I don't think most of its contents show up in this cap. I think they show up in the cap that talks about the transaction lifecycle and access to the ledger, which will be coming later. But I can reiterate in this cap that there is essentially we're not going to be supporting any of the WASM multi-threading proposals that are floating around in the future for running inside one of these VMs, and that the multiple VMs that exist inside of a host context that are described in this cap are intended to be strictly serial semantics, and that all of the objects would be private to that single thread that are described in this cap so far.
Okay, cool. And so everything else other than floating point is like completely well-defined in the WASM spec. Like if you shift a 32-bit number by more than 32 bits, like that's like, what does that do, for example?
Yeah, that is well-defined in the WASM spec. There are, as I said, there are two floating point idiosyncrasies. They're actually not the ones you're talking about. There's NAND normalization, which all of the interpreters we've been looking at have some option for normalizing NANDs after every operation. It's just expensive to do. And the state of the floating point environment flag. So you have to, there's a hardware environment, the floating point environment, which controls the rounding mode and the exception propagation mode, whether the exceptions are eager or quiet. And that is assumed that it's something you have to set. And as a host environment, you have to set it to a particular state before you invoke your WASM code. But there's no interface for changing it from inside the WASM code. So, so long as we specify what the settings of the floating point environment are, it would be deterministic with respect to that. It's just that WASM as a spec doesn't define what you will set the floating point environment's settings to.
So what happens if you right shift a 32-bit integer by 32?
I don't know off the top of my head. You'd have to look at the spec. I don't have the WASM spec memorized, but it's very, very well defined. Okay. It's one of the most well-defined VMs out there. I think probably that's ever been done. There was something else you were asking about though. Oh yeah. Everything else in WASM is very well defined. The big caveat in my mind is that there are no host functions specified here, but there are a bunch of host functions implied by the data model, right? Like there's a map and a vector and a big num. And you only have those data values if you expect to have functions that operate on them. And a completely reasonable objection and caveat that one might have to this cap is I don't think it's possible to specify functions on this data type unambiguously. So we should leave it out. And I think that's particularly when we're talking about cost models, that's something I'm somewhat concerned about, is making sure that we're only including data types about which we can plausibly believe that we would be able to construct correct or at least worst case cost models for any of the reasonable operations that would be implied by the presence of that data type. So big nums imply there's going to be big num multiplication. Can we figure out a reasonable worst case cost model and make sure that that's correct? I think we probably can. That's why I included big nums. I think big nums are reasonably well studied, but if that strikes at the heart of fear of non-determinism or fear of impossibility of bounding cost models, I think that's something that would be a very reasonable sort of point of debate on this cap, is like, please leave this out because it's too scary.
The host objects, any of those in
the
cap itself, like actually doing an exercise to create and enumerate on any of those in the cap itself, or is that something that's just a bunch of unnecessary work?
The thing is, we don't have, at least I'm not really expert in cap writing, but it seems to me that we don't have a section in caps that's sort of like miscellaneous discussion or speculation. And that's really what we would be doing there. We would be speculating forwards to future caps and saying, and that's what's unusual about this cap, is that it is really incomplete. It's not a whole feature in and of itself. I say in the preamble to it that there's actually nothing new that a user can use here, which is a little bit weird for a cap. And so it might make sense to include in that preamble or in the context or justification or section or something like that, a little bit of forward speculation about, we assume that the following things are going to come. They'll probably look a little bit like this, but we're not specifying them here. It's just like for context. If you like, I'm happy to add that.
No, it's okay. I think we are going to have those other caps, like the host function cap, for example, is one that we need to kind of lay out as well, right? And we have a different cap, I think, that will be around the cost model and things like that, limits and cost models. So it's fine. It's more like, yeah.
Right, so all that stuff's
Right
getting
now.
covered in separate caps.
Right now, yeah, like we started to do that with SpeedX, actually, the whole like split up, you know, like an actual protocol into many pieces, so that we have like, you know, parts that we can think about, discuss, and there will be some of that here as well, of course. I think we want to probably leave. Yeah, I was going to say real quick, like, yeah, I think we want to leave some time to also talk about the other topic for today. So yeah, David, you have another question?
Oh yeah, what? So I guess I'm also trying to understand, like, so you can have like a 30-bit number either as a value or as an object.
A 32-bit number. There's no object type for a 32-bit number. There's only a version embedded in value because it always fits in value. Value is a 64-bit type with a tag union on it, so there's no reason to ever box it essentially.
Sorry, so you have this part where you say like the data values that are shared are 32 and 64-bit numbers, floating point and integer, and then you have these like tag types that include a 63-bit positive number and like a 32-bit unsigned integer and 32-bit signed integer. So how do those, like, what's the relationship between those and like the fundamental values then?
I see. Okay. Yeah, sure. Happy to talk about that. So the point that you're reading is that there are exactly 4 types of data values shared between guest and host. I'm maybe being splitting hairs in terminology here a little bit. These are essentially the data values mandated by the WASM interface. So these are the only possible data values. There's no way for us to talk about a data value that is not one of those 4 when we're calling a function, for example, and passing arguments. The only argument types are those 4. So,
I see, but you're saying we don't have, for example, a 64-bit integer. Like we even though we can pass a 64-bit integer, we always interpret it as one of these tagged things.
Yeah. So what comes later on is and I should actually clarify sort of that layering here is that we're picking just the 64-bit type. We're actually only using the int64, and we're saying every value we pass back and forth is going to be an int64, and we're going to use it as a tag union inside of itself to carry a bunch of different stuff. Some of which can be a 32, some of which can be an object reference, some of which can be a small symbol. There's a bunch of little values in there.
Okay.
Well, should we move on and talk about the next agenda item, which is interoperability? There are a couple of questions here that I think.
Yeah, I think we can ask more questions on the dev mailing list on the runtime.
Okay, cool. Let's switch topics then. So, excuse me. On the topic of interoperability, my questions kind of come back to the same kind of thing that David opened up with, which is like, what are the requirements? I've been thinking about this for the last like 10 days or whatever at this point, but it's really, really vague what we actually want. And one of the big questions that we keep coming back to, that keeps coming up in conversations that I'm involved in, is like, what should a smart contract on Stellar be able to do? And one of the examples that keeps coming up is like, one of the things that becomes very centralized on Stellar today is managing the authorization for an asset. Like what if you want to have like a daily transfer limit or something like that? Like these are things that are really annoying to do because it all has to be done through like a central server, et cetera. But a smart contract could fulfill this role in theory. Do we want to make it easy for smart contracts to do this stuff, where basically they become like a gatekeeper to Classic? Or do we want to not make that easy and basically say like, hey, if you want to build these kinds of things, just build them entirely in smart and get the features there? And these are the kinds of questions I'm interested in at a high level. And there's more to like how this is structured, but first let's just open this up with like, Do we think those kinds of things should be possible, or should we just say like, hey, just like do that in smart?
And to help me like understand the actual question on this, like the low level type of super granular access control example, like the question there is like, should people be able to do like a normal like classic looking payment and it still ends up being gated by some smart contract? Is that what the question is?
I could supply an example, but
I mean, I understand the use case. It's more like in terms of what is the question on how is that really related to classic, I guess?
I guess the way that I'm imagining any of this stuff working is like anything that comes through, like anything that a smart contract is involved in originates on the smart contract side. So you would imagine basically saying like, hey, I'd like to make this payment, but then the smart contract does everything, all the operations and stuff. It's basically just a gatekeeper. It's like, okay, like you can do this, and then it goes and it issues the allow trust, and then it issues the payment, and then it issues the revoke trust, and etc. And it does all of that on the classic side, basically it's controlled by smart. So you don't submit a classic payment anymore, but everything is kind of happening classically, including all this allow trust stuff, which adds a lot of complexity, as we know. So I think like the payment alone is kind of an essential building block. You can't have smart and classic like not even be connected by payments. That wouldn't make any sense. But the other stuff, managing trust lines, managing signers, managing authorization, all this other stuff. Do we want to allow that, or do we want to just say, okay, like you can't do that from smart?
I mean, I think that, yeah, this is exactly getting to the core of like why I want the requirements document, because like one thing that so definitely like managing trust lines and allow trust is like a big pain. It's like something you might want to do is write a little smart contract that says that, if so-and-so has authorized you to like hold their asset, then like you can automatically hold my asset, right? So like, is that the kind of thing we want to support? And if so, that requires like a fair amount of like a fairly wide interface between smart and classic, right? My bias a priori would be to say that we actually want that, because at the end of the day, we want transactions to be as cheap as possible, because that's always been kind of the stellar way. And so the more we can kind of like leverage stuff that's implemented in C++ and that's potentially sort of optimizable through maybe even future things like SpeedX, like the better. It also, of course, makes it easier to debug. It's, makes interoperability better because everyone's speaking like the same language, using the same objects. But again, it boils down to requirements.
So I can, while we don't have this document of requirements, I'm happy to throw some out there. One of the things that are very important for our ecosystem is that existing services and existing stakeholders don't become deprecated. So we're talking mostly about exchanges, about issuers like Circle. We want to make sure that their asset is still viable and fully functional with the new smart world. Now, to what extent is it just like a user just like moves their value into the smart world and then like it's a whole different primitives? I don't know. That's kind of like what we need to figure out. But we do want people to be able to issue smart assets as well. That is, a lot of issuers are using things like SEP8 today to do things like, various velocity limits or like minimum balance on their native asset, on their issued asset limits. And today that it requires a lot of finagling. It would be great for people to be able to issue them similar to how ERC20 tokens are issued.
But we could keep SEP8. So in other words, like there would be a new signer type, which would be like the smart contract endorses, and then you could just kind of like do it through the smart contract, but like we would keep the same framework or not, right? Like
Yeah,
this is the kind of thing where like
I think you're getting into implementation here.
Well, I just am getting into whether how you choose this actually affects Cap 46, like whether certain things are a good idea or not, or what base objects we might want to have supported. And so, like for example, one thing that is not in here is any kind of capability, right? that I can tell. So like if like a smart contract wanted to like invoke some privilege or sign some other transaction, there'd be no way to do that. Maybe privileges or whatever you want to call them need to be a kind of first class thing.
By privileges here, do you mean like a contract has the privilege to do a certain action on a certain account that is not the contract's account?
Or it has a certain signing weight or something. Yeah, exactly.
Yeah, this gets into the second part of my question in the document, which is like the relationship between like contract signers accounts. And like Leigh has proposed this. Is Leigh here? I don't know.
Yes.
Oh,
Yes.
Hi there. So Leigh has kind of proposed this model where like maybe a contract should be a signer in some sense. Like if a contract can generally control an account's trust lines, data entries, whatever, the account itself, then it should be a signer on that account. And for a variety of reasons, maybe it should be the only signer with any weight on that account. So it has like exclusive control. But in this world, like you could still imagine the kind of case where you want like a one-off, right? Like I want to allow this contract to like withdraw funds from my account right now, a certain amount that I believe is going to be withdrawn, like $100 or something. And this gets like a little weirder. It's like, well, what do you do? Do you say like, okay, like the transaction that runs this smart contract invocation, like the account signs that transaction and that's what gives it the authorization. But how do you be certain that the smart contract invocation at the time you actually run it is going to do the thing that you thought it would do? It's a little different from like a seller contract where you're like, this is a payment for $50 signed. And that's where I think these kinds of privileges come in. Like either you give the account like one-off control of your entire account at that signing weight to do anything. You say medium, well, it can do anything at medium, whatever it wants. Or do you need some better control? I don't know. What do you think about this, David?
I mean, yeah, I think that again, not to sound like a broken record, but that like there are many possible answers here. And a priori, without having the context of requirements, my kind of inclination would be to make privilege something. People tend to run into problems with like ambient authority, right? When it's sort of like anytime you do something, it's like if there's any possible way you're allowed to do it, like you can do it, right? Think of all these like time of check, the time of use bugs and stuff that happen in Unix. And so to have some notion that a smart contract has privileges and that it needs to explicitly invoke particular privileges, like maybe there's a smart contract that we want it to have power over two accounts. And so it has two different privileges. And when it's doing something, we want it to literally specify which of those two privileges it wants to do to avoid, a kind of confused deputy problem. So without knowing the requirements, I would say like, I would like to, it seems to me like maybe a good idea to have privileges be like a really explicit thing. But again, it's a little abstract right now.
If I could just chime in on one thing with respect to vocabularies and Cap 46. This is just a minimal prefix, right? This is the set of host objects we can think of right now. So you get to add new ones in the future. If we don't have to have a complete list for this. Is all I'm saying.
Sure, but getting the sort of privilege model right from the start is probably a good idea. Like, I don't know.
There's no concept of a privileged operation here because there are no operations. So we don't. I guess all I'm saying is we don't have to worry about whether privileges are properly modeled in this cap. We can say that is a thing we have to decide, but it doesn't necessarily hold this cap.
One thing on the topic of privileges that I think is relevant here is like the bigger we make the like interop surface area, the more complicated the privilege system has to be. If the privilege system basically amounts to like, you can only make payments, then it's like, okay, like how much payment can I make? From what account to what account? For what asset? Yeah. That's like the whole space.
I think
sort of, unless, sorry, go ahead.
I think it gets a little bit, more complicated about that. And like, Do we say that you can just do payments, or do we say that you can do payments at frequency, or like how the number of cases, like we're almost saying that permissions are almost a contract that you can implement. We've talked about privileges and permissions before, but I don't think we've really talked about how do we make it so that people can innovate on them? Because we could define some basic privileges, but then people will be stuck sort of what they have today with classic Stellar, that there'll be limitations that they're trying to like work around, or they end up just going and building their own ERC20 like contract just to completely replace the entire system because the permissions don't give them access to what they want to do.
I mean, I guess one of the things I'm saying is that Stellar actually does already have a notion of permissions, right, or a privilege. It's called signing weight. And so we haven't really sort of formalized it or maybe like expressed it this way, but without knowing, as a first draft, we probably want privilege. We probably want to use that exact same structure and not introduce something new. Like where things tend to go wrong is if there's like two different, ways of talking about two different privilege systems that are kind of operating on the same objects, then you get like weird loopholes where people can, there's like a gap between the two that can maybe be exploited. So,
but the signing weight it's a really, really weak privilege system. That's what I was talking about at the beginning of this, where it's like, I'm authorizing a contract to do stuff to my account at medium signing weight. What am I authorizing it to do though? Like, unless I've audited the code, the contract might do anything. It's way more complicated than looking at a set of a list of operations.
The contract is code, so it can only do what the code can do, right? So
sure, but I mean, like what it might do could be complicated. It might actually even be very difficult for me to predict at the time that I sign the transaction. Like imagine a contract where it has two functions. One function is, hey, set a number. And the other function is, hey, whatever number was set most recently, extract that amount from my account and send it to the contract. There's no way I can know what the contract is going to do when I sign for it.
But at the time you add that contract, at the time you give that contract signing weight on your account, there's presumably some reason for that, right? I mean, you decided you wanted to this contract to have access to your account.
Sure, yeah, but like I don't necessarily want to give it unfettered control over my account, right? Or even very strong control.
The contract is code, right? So the contract does what the contract does, and you decide whether or not you want that to have access to your account, right? If the only thing a contract does is manipulate the authorized flag on trust lines, then you look at the code and you say, great, like I don't have to worry about this draining all my lumens by signing like huge account fees or something.
What if the contract is mutable?
Well, okay, so that's something that needs to be driven by the requirements document. Do we need mutable contracts, right? And if that's
general consensus in this room is yes.
What?
That question, there's general consensus on in this room, and the answer is yes.
Okay, well, I need to be convinced. Like, I'm not saying that you can't, but like, show me the requirements that tell us we want that what we want cannot be achieved through like multiple releases of a contract, as opposed to like having eval in an actual contract.
Right, but if you have multiple releases and a point of indirection, which is the pattern people have when they only have immutable contracts, is they have a point of indirection like a proxy or something, and then multiple releases, you still have the possibility, the requirement, in fact, of people delegating authority to the indirection point with permission and saying, I give permission to this indirection point, whatever it happens to be pointing to right now, to do something. And so you're right back with mutable contracts. People will work their way around to something that is behaviorally equivalent to a mutable contract that has whatever permission you've given it. They'll either invent it directly on top of mutable contracts or via whatever indirection system you build instead.
I just want to say we are pretty much out of time. So if this feels like a great last question, I'd say ask it. If not, maybe we hold off.
Well, I was just saying, like, you can have your contract not have direct access to the account, but just have access to another contract that only does certain things, like not the things you don't want it to do. But anyway.
So it seems like a requirement. We just keep coming back to this requirement stock that you're requesting would be the
Yeah.
thing that would help guide us figure out the answers to these questions. Okay, cool.
I'd also like to propose perhaps moving this meeting to the Dev Discord and having it weekly instead of every other week, because there are going to be a lot of questions that we need to answer and do it quick with Jump Cannon.
Cool. I mean, I think that we should ask that offline and just verify that that works for everybody and look at calendars. And I can do that after this meeting. Awesome. Thanks, everybody. See you next time.